Sounds good.
Okay. And let's select the slideshow. Okay, so a little bit of introduction for those of you in the meeting and those of you watching at a later date. My name is David Carter. I stumbled into the materials subsystem quite accidentally through the Rocket Workbench, which is an add-on I've been developing. I've been a programmer since the early 80s. My first computer was a TRSA Model 1 I bought in college in 1982. So I've been at this a while. And of course, I got messages popping up here. I don't know if you're seeing that on the screen or not. Let me kill my mail client so we don't keep getting interrupted. Okay, so the target audience for today is really developers. And that is developers of FreeCAD, obviously, but also Workbench developers, maintainers, things like that. So what I'm trying to give you here is an idea of how the material definitions work and what are the possibilities in terms of applying that to the different workbenches and different workflows. Okay, so that's really the purpose of today. What isn't covered, I'm not going to be covering how that's going to be applied to appearance, to physical properties and things like that. That's still work that is yet to come. So it's a little bit outside the scope of this particular discussion. In terms of questions, I will pause for questions at the end, but I don't want to interrupt the flow of thought here. So if you have questions, by all means, just speak up. If it becomes cumbersome, then we can defer later. But for now, feel free to interrupt. Okay, so one of the first concepts I want to discuss is that of libraries. Okay, so materials already have libraries. Currently, there are libraries in 3 potential locations. The system libraries, which include the standard list of materials that you're already familiar with. User-defined, which a lot of people aren't really familiar with, but this is a section in your user folder for FreeCAD. So as you download modules, there's a folder in there that's created and so on. And similarly, there's one for materials. Okay, so even with up to 0.21, you can create your own materials and drop them in there. And you can also specify a custom folder, and you do that through the preferences and just select a user-defined location. So browse to your folder on your local system and so on. Now, with the changes that are being introduced at this point, there is a new library location and, well, potentially multiple, but each add-on workbench is capable of adding their own. And we'll talk a little bit more about that later. But for example, my Rocket Workbench has a number of materials that it imports from other products, and I can add that to the material subsystem, and it gets loaded as a standalone library. Okay. Now, in future, these libraries could be augmented. Some current thoughts on this, and they're by no means firm, so there is time to adapt if this is unacceptable. But in document, so each document can be treated as a library. There can be materials inside that document that are unique to that document. Now, obviously, you can copy those definitions across, so you can create a card on your local file system from that in document one if that's something you desire. But that would be a very useful feature for particularly for small modifications. And I'll get into the inheritance of materials a little bit later, but this is where you're just modifying or tweaking small parameters. There will be an API for add-on modules that will allow a much expanded type of material library. So for example, right now, all of the material libraries are in the local file system. But with the add-on modules, you will be able to add materials external to FreeCAD in a database or as part of a web service. You can even use Git. You can use remote storage like Google Cloud or whatever you want to do. So it's just a matter of obviously writing a module to do that, but we will have the APIs available for you to do that. So that's a pretty interesting development. And I'll show you in the editor a little bit later how we separate those libraries. So there are some capabilities introduced with the new material editor, and the big one is folders. Up to now, the material cards have all been in a single folder, which is just a flat file, a flat definition of it. So, for example, if you're in the editor, in the legacy version, you use a combo box to select your material. Now that's fine when there's only 30 predefined materials. But my Rocket Workbench, for example, adds over 300 materials. Okay, so that very quickly becomes unmanageable. So what the material editor introduces is a folder system, and you can arrange that folder however you want. And I'm actually going to bring it up here right now and show you that. Okay, so right now I'm in the material workbench. This is a development branch. It's not what's currently in the mainstream. So two aspects of that is, one, I fixed a lot of bugs that are currently in the mainstream. So this is going to be a little more stable. But two, there's the potential for bugs I'm not aware of yet. So Murphy's Law of Demonstration will probably show up today. So from the material workbench, we've added this button currently, which brings up the editor. Whether or not we keep that in the final version is a point of debate at this point, but for now it's here. Okay, so we bring up the material editor and we see we have the folders. Okay, so in the system library is what we would have currently in up to version 0.21. Okay, so we have appearance, material definitions, which just define the physical look. We have fluid materials and the standard materials, which are the physical definitions of materials. Okay, but you can see in my Rocket folder, this connects to my add-on module. I've got a very large list of different types of materials. Okay, now I have not tried to organize these into folders yet. That'll come as I develop this a little further, but right now it's designed to be interchangeable with the current legacy editor. Okay, we have the user library. So this is the one I mentioned earlier. That's in your user folder. So that would be, let's bring up the slides here. Wrong way. Where am I going? There we go. So it'd be in the user folder. In my case, users, decarter, app data, roaming, FreeCAD material. Okay, and you can see this one I do have arranged in some folder format. Some are a lot are in the root, but pay no attention to the names. I'm making up names as I go along for testing, so they're not indicative of anything. Okay. The other big thing is flexible property definitions. So this is a real big change from the way it's been implemented up to now. In the previous editor, there was a single file that listed all possible properties. Okay, it wasn't really extensible. There was some small capability for adding new properties, but it wasn't very advanced. So we've totally redefined how those property definitions are defined in here. And I'm going to go over that in detail in a moment. In order to maintain compatibility, especially during the development phase, there are a couple of things that have happened. One is the new editor is able to read material definitions in the old format. And that will continue going forward. The difference, though, is you will have to actually save it in the new format before you actually use it. So it can be read, it can be displayed, but you really need to save it before you can reuse it. Now, when you save it, it's going to overwrite the previous version unless you save it under a different name. So you're going to lose backwards compatibility. You won't be able to open it in a previous version of FreeCAD anymore. There is a Python utility for bulk conversion of files, and that's how I've converted all the system files, for example. And that's called convertfcmat.py, and it's in the folder. Okay, the legacy editor. So by default, when you start up the development version, it is going to use the old version of the editor. Okay, so let's go to the preferences. So in the preferences under material, there is this one, use legacy editor, and it's selected by default. Okay, so I'm going to show you what will happen there. Now in the material workbench, it's always going to bring up the new editor. But if you're in one of the other workbenches, like FEM, for example, okay, and we click on the material editor, it's going to bring up the old version. And I have a cat on my keyboard. Okay, so if we then select the or unselect that option, yeah. Let's see. Okay, so by default it is selected. When you first load it up on your local system, it's going to be selected. So you're going to have to turn that off in order to see the new version. And then selecting the same option will bring up the newer version. I am going to go back to that other one for a moment to show you. Yeah, I don't know. Okay. So this is another aspect of the compatibility. If you look into the material cards, all of the new and the old ones both show. Okay, so you can open the new cards in the new editor, but if you save it, you're going to overwrite the newer definitions, and yeah, so you don't really want to save the new ones, but it is going to interact with the old ones quite fine. Okay, so there's not a lot of information in there. Now with the old editor, you have the properties all displayed in a single view. And again, it's not a flexible list of displays or properties. If we go to the material workbench, somewhere, there it is. Okay. When we select a material, it's broken out into properties and appearance, and only those properties that are defined are going to show in the editor. Okay, so you can add a property easily. At this point, we have father, density, isotropic linear analysis, and thermal. If we want electromagnetic, for example, we would select it here. There's a number of properties in there. Okay, and then we have the properties in our list. Okay, and I'll show you how those properties are defined here in a moment as well. Okay, until you have the values in there, obviously they're not going to show. Just adding the property does not give any default values. You're going to have to fill in values for those particular parameters. Okay. Now in this particular case, libraries also have the attribute of read-only or read-write. Okay, so the system library, and optionally, depending on how they've defined it, the workbench libraries will be read-only. Okay, so I won't be able to overwrite the system library for Calculix Steel. If I try to save it, it's only going to show me those libraries that are writable. Okay, so I can save it here. Okay, and if we go down to our user libraries, we see we now have a version of it here. Okay, and that's the one that's going to load by default. Okay. So the properties. This is, like I said, one of the big differences between 21 and the current development. Instead of a single monolithic list of properties, they're now broken down into individual YAML files. A property is defined by providing a name. Okay. It's got a unique UUID assigned to it, and that's how it identifies things. Okay, so if we save a modified version of it, it'll have a modified UUID. It won't be the same property as before. Okay. URL description. DOI is a document object index, and this is a capability for researchers that allow you to directly link to the research papers associated with this property. And I have an example of that I'll show you shortly. And then you define the properties. So bulk modulus, it's of type quantity, units is kilopascals, there's a URL and description. Okay, so again, there's no values at this point. It's just describing the property itself. And you can have as many or as few as you require. Okay. At the moment, there's no editor plan for the model properties. You're going to have to go in and use your favorite editor to modify the YAML file. And there's a few reasons for this, one of which is that it's not an operation that most people are going to be doing. Unless you're someone who's, for example, a materials researcher or the developer of a workbench that's going to require specific properties, it's not something that's going to concern you. And if you are the developer, you have the skills to create the YAML file. And if you're a researcher, you have grad students who are basically slave labor, so they can do it for you. But if anyone encounters an issue where they're just not capable of creating the YAML file, I mean, by all means, contact me and we can pump something out pretty quick. Okay. Another key thing about properties is there is inheritance. So in this example, we have the linear elastic property definitions that includes all of the definitions for density, which is a single property density, all of the definitions for isotropic linear and elastic, which is like Young's modulus and Poisson ratio and so on, plus everything else that was defined in the previous version. So this is the one that matches the mechanical properties from versions up to 0.21. When you run the automatic converter, if it sees any of these properties defined in your material file, it'll add that as a list of models that it requires. Okay. Now, models have been separated into physical and appearance models. Look at some examples here. Those examples don't have it. Let's bring up one that does. Resources, models. Okay, so for the appearance models, it has the header appearance model. For the non-appearance models, it'll just say model. A file can include both and often will. The actual types of properties are the same across both, but it does, its primary purpose is to separate it out in the editor so that, for example, we can differentiate between appearance and physical properties. Okay. So the inheritance, there's a section in there for inheritance. It gives the name of the property model you're inheriting and its UUID. Any of the properties that are defined in here do not need to be respecified in the following files. Okay, and if there are overlaps, it's going to take the earlier definition, not the later one. Okay. So what are the property types? Well, there's a number that are existing in the current material system. There's Boolean, integer, which, to be fair, is actually an unsigned integer, so that that's a distinction worth noting. Floating point, string, quantity. So a quantity is the FreeCAD quantity, where it's a value with units. Okay. Color. Color is a tuple of RGB, RGBA. I can't remember exactly what that last letter is, but it's a tuple of numeric values. An image or a file. Now, the image in this case is still just a path to a image file. It does not have the embedded capability at this point, but that's something that may not make it into this version, but certainly would be a future development to allow that embedding. And of course, a URL. There are some new data types that are introduced in this version, and they are 2-dimensional and 3-dimensional arrays. Okay, so I have some examples. Arrays. Okay, so we specify a two-dimensional array, and then we define the columns. Now the columns are basically the same as the attributes that it would be for any other type of property. So in this case, we're going to have a two-column array with temperature and density. The type at this point is restricted just to quantity. There are good use cases for having other data types in there, but for the first implementation, quantity is the current restriction. So that'll evolve with time, but for now, we're sticking with quantities. Okay. For a three-dimensional array, it's a similar. You have a minimum of 3 columns defined, with the first column being the Z or the depth variable. Okay, so let's see how that works in a material. Okay, so this is a material that has the two-dimensional array and the three-dimensional array using the property definitions we just looked at. We double-click on the density one. We see that we have temperature and density as columns, and we can add however many rows we require. Okay, and to delete it, we can either hit delete or delete row. Okay, so select it, delete it. There is a default value here. So in the event that you're just calling for a single value, if you're not array aware in your application, you can still get a useful value out of it. The restriction here is, and it's not enforced at this point, that'll be coming, is that this value must be obtainable from the data given. Okay. The intent, and it's not implemented yet, is to have these interpolated. So for example, I could get a value for 25 by doing some curve fitting. Okay. Three-dimensional arrays are similar. Okay, so we have our depth dimension, which has a number of two-dimensional values. Okay. So in order to delete anything here, unfortunately, the delete key won't work because it doesn't know what table you're working in. You might want to delete from the depth, which would delete the entire table, or you might just want to delete a single entry. So you're going to have to right-click in order to do that. Same thing again, you're going to have a default value that's going to refer to this column here. Okay, any questions on arrays? Because this is actually a pretty substantial new capability, especially for things like finite element analysis and computational fluid dynamics. You can actually add a lot more interesting things in here. Okay, well, we'll have questions at the end as well. Okay, so some future types we might be able to add. One is enumerations. As an example, you could have a multi-dimensional array for tool parameters for the path workbench. Okay, so depending on what type of operation, you're going to have different feeds and speeds. Okay, so you want an enumeration that would specify that. Now, of course, that requires us to support other types of properties in the arrays, so it's a future capability. Okay, but something to be thinking about it. Python calculators. Well, I'm going to show you one of the models and explain why that's useful. So isotropic linear elastic has 4 properties: bulk modulus, Poisson ratio, shear modulus, and Young's modulus. You only need 2 of those. With any 2, the other 2 can be calculated. Okay, so what would be nice is to have a bit of Python code that would see what you have and then figure out what the other parameters are. Okay, so that's a capability that's not in there yet, but I would certainly like to add there in the near future. And the way that's going to work is you're going to specify what Python module it's in, and then obviously what function to call in order to do that calculation. Okay. Distributions. One of the reasons why distributions isn't in there currently is because it's kind of hard to see where it could fit. It is very easy to define I have a sneezing cat. It's very easy to define a distribution that is, just the distribution values with a unit similar to a quantity, but it may be desirable to have a distribution for other values as well. So that's something that's still under consideration. Okay. But this is another possibility where we just have the distribution as a data type. So for example, the Gaussian distribution, the parameters that define it, give it its units and so on. Kind of in the way, Kitty. Yeah, that's my biggest problem as a programmer is my cat. Okay, standard property models. This is the part that gets most people confused and has prompted the most discussion on the forum. It's like, you're not including this value, or you're including that one that isn't required. Okay, so here's the first point, and I want to emphasize it. I don't care. There is no standard. The whole point about this system is if something is missing, you can add it. If it's extra, you can ignore it. Okay, so that is the whole point of this exercise. Honestly, it's the reason, one of the main reasons why I wanted to give this talk. There is no standard. Now, there are some that are predefined, okay? And for example, for legacy support, in order to convert all of the existing model definition or material definitions from up to version 0.21, they specify a certain set of properties. So we have some compatibility there. But even then, it's broken down. It's not the same monolithic definition file. It's broken down. So we have architectural, we have costs, we have electromagnetic, fluid, some others like Father, material standard. They're not really well defined. So, they go into their own. And depending on where they're used, you may or may not require them. Okay. Some will be required for core module support. So for example, the isotropic linear elastic that's showing here. Okay, those properties are definitely going to be required if you're going to be doing any finite element modeling. Okay, so that's Young's modulus Poisson ratio. So if one of the existing core modules require it, obviously we're going to have a property set to support it. Popular module support. So CFD is a popular module that isn't in the core, but if it requires certain properties, then obviously we would want to include that as part of the standard definition set. I have some in there that are just useful examples, okay? And I'll bring some up and show you. Where are we? Okay, so let's add some properties. So there are a couple that are interesting here. Orthotropic linear elastic. So this is a case where your material properties are different in different directions. So the x-axis, the y-axis, the z-axis may have different shear values, for example. And a classic example of that is wood going against the grain or with the grain. Okay, so we can add these. Okay, so now we have those parameters in the various directions. Now we could also have implemented that as an array. So really, I am going to defer to whoever is trying to use this property in either finite element modeling or CFD or whatever to provide some feedback on what they would like to see for this model. Another one that is an interesting example I got from talking to a materials researcher. Now this is interesting in a few reasons. Okay, so there are a number of properties in here, various coefficients, moduli, and so on. And I know nothing about this. I can't explain it, but there is a research paper that does. Okay, so this is the DOI. I click on the web link on the wrong window, of course. It links me to that journal article that describes those properties. Okay, so this is definitely a nod to the materials researchers who will be using this. Community agreement. So this is important. If the community decides that we need a model, or that a model is probably not broken up into enough pieces, then we can fix that. And the first one that's under discussion where we need that, we don't need that, is really the appearance models. So if we're going to be doing textures, for example, bringing in wood grain and things like that, the model is going to need to support that. But there are also other models that might be used by the I forget what it's called now, but the various workbenches that do visualization. Okay. And if you want to add your own visualization, you might need your own properties and so on. And if that becomes popular enough, the community thinks that perhaps those definitions should be in the core models, then that's obviously something we can add. And as part of this effort, I do submit that prior to release in version 1, we have a discussion about what those properties and what those models are going to look like. What I've done right now in terms of defining those materials and in terms of organizing them in folders and things like that is just my first pass. I don't assert that it is how it should be. It's just what I've done. Okay, so as we talk to like Yorick of the Arch Workbench, the developers of finite element modeling and so on, the appearance developers, we may want to refine both the property definitions and the model definition or material definitions. Okay, so very much open to the community for discussion. Okay, materials. So materials, as we've seen, are made up of models. You add the model definition and then you provide a value. You add the models as required. If you don't require them, they're not in there. Okay, so there's no extra fluff. If there's no value provided, that property will be ignored. Okay, there is inheritance in the material files as of this morning, because I just finished implementing it. And the intent for that is, for example, if I have Calculix steel as my base steel model, but I've tested my steel in my own lab to get its characteristics and they're slightly different, I can create a derived model and it would only have those saved values. Another place where it has been very useful, if I look at the model definitions, where am I? Okay, so let's look at that Calculix model. Metal, steel. Okay, so this one inherits a model called steel, and that steel is actually an appearance model. Okay, so there's all our appearance properties. So even though the Calculix file has no appearance properties defined other than what it's inheriting, all those appearance properties are in there. Okay, so if I go into Calculix steel, okay, so the physical properties are what are defined in Calculix, and I also have my colors, which are incidentally very poorly defined. Now, these color definitions that I've used are the ones that are hard-coded for appearances in the product currently, and they're inadequate, I guess is the best way to describe it. These are all going to have to be revisited by someone more knowledgeable than me. The previews here, this is the same method of preview that we had in the previous editor, and it is, again, totally inadequate. It uses the diffuse color and the specular color. Okay, so if I change that, for example, let's make it something blatant. Okay, but if I change the emissive color, the ambient color, the shininess, the transparency, they don't get reflected in this appearance here. So this is going to have to be, yeah, it's going to have to be improved. And that will probably be done as part of the appearance subtask. Okay, so inheritance is very important in models. Now, when we do the inheritance, it's not all in here, but we can inherit from, so we can change what the base model is for this one, or we can inherit a new material. Those aren't implemented yet. We have inherit new here. So I have Calculix steel. I click inherit new, okay? And it has all of those parameters from calculus steel, okay? So now if I change the diffuse color for steel, and I save this, and I'm going to overwrite that one. And now when I bring up that file, okay, you see it's inherited from calculus steel, and the only value it provides is that changed diffuse color. Okay. So again, this gives us another number of possibilities. Now, one of the best things about this in terms of appearance, and one of the reasons why it was so interesting in the first place, is, like I said, steel is a pretty horrible color definition. It's not the only one. There's a lot of horrible ones in there. But by inheriting steel for all of the steel physical definitions, we can adjust this and it would get updated for all of them. Okay. Now, that's an important point as well. Everything is referenced by UUIDs. If you change a material, if you change a property, you really should have a new UUID so that it doesn't get confused with the previous one. Okay. Now, there are cases where you do want to overwrite. So, for example, before we release, we'll want to overwrite these color definitions to something more appropriate, in which case it'll still use that old UUID. So when we are doing our inheritance, you look at the calculus steel, we are still going to reference that UUID. Okay, but that is one of the tricky things about having this approach to materials, especially with the folders, because you can't just go by name anymore. There has been a lot of discussion about version control on this, and basically it's going to fall to the user. They have to know that if they're going to have a modified version, I will put warnings in there that they're going to be saving over an existing definition, and that this will have impact. So it's going to be up to them to update to a new file versus an overwrite. Okay. I'll manage that as best I can, but at a certain point, it's going to come down to the user. And one of the best ways to manage that, like I said, is just to give them warnings about the impact of certain operations. Okay. And again, things like the standard library that's included with FreeCAD, that's a read-only library. So you're not going to be able to overwrite things through the user interface. It's not truly read-only. You can still go in and edit files from the Windows Explorer, for example, but you're not going to be able to do it using the standard user interface tools. Where are we? Okay, selection filters. So as an example, when I brought up the list using the legacy editor of materials in the finite element modeling workbench, it only showed the models that had physical values. Okay, it did not show appearance only definitions. Okay, so we can do some filtering like that. As we bring up the editor, it will be possible to specify various filters, such as only models that implement the electromagnetic model, for example. Okay, so you can very quickly narrow down based on your application what options you can select. Okay, there is a concept of containing a model and containing a complete model. So again, using the isotropic linear elastic as an example, there are 4 properties in there. Typically, you only need 2. Planning on having Python, so it'll automatically fill in the other 2. But by requesting a complete model, if the model does not have all values defined, it will not be returned. Okay, so that simplifies a lot of the error checking operations you have to do as a module developer. I want something that has complete linear isotropic analysis or complete isotropic linear model, data model. Okay, so I know that every item returned will have that complete. Okay, and that's enforced using the APIs. Okay, interfaces. So this is where you as the developer come in. So the old format was a property dictionary. When you get the material card, all those properties from that monolithic property definition were returned as a Python dictionary. This is supported in the new system, but it is at its introduction considered a deprecated interface. Okay, it is not something that you should write new code to use. It'll probably be there for a while, but version 2, version 3, whatever, it may go away. Okay. It's not going to support newer capabilities. So things such as arrays, you're not going to be able to access through those dictionaries. Okay. If you need to do arrays, that's new development anyway. So using the newer API shouldn't be that much of a stretch. The APIs are available in both Python and C++. So no matter what you're developing in, you'll have access to it. And that'll make it accessible to macro developers and things like that as well. Okay. The preferred method of access is the API. And again, if you require the newer capabilities, even though the APIs don't fully define it at this point, that's how you're going to have to access them. Okay, so what documentation is there on the APIs? Well, at the moment, there's not a lot. That'll change with time, of course. So the major places you're going to go for documentation are, let's close down the resources. For Python, there's Test Materials app, and there's a routine in there for working with Calculus Steel. Okay, so that is kind of the sample material. Okay, so it shows how we're loading it. We're loading it through the UUID. And typically you get that UUID by selecting it from a user interface element. So it's not something you have to know. Yeah. And then we can get the various properties. So this is where I mentioned that we can check for models. So does it have a specific model? Density, isotropic, linear elastic, and so on. Does it have an appearance model? Basic rendering. So, okay, it can have those, but is it complete? Okay. So in some cases, for example, this is the isotropic linear elastic. It's not complete. Okay, because it still has those two values missing. Now, the old interface was through, well, actually, back up a sec. This is still the new API. We can look for specific properties and see if it has it. And then we can also see if it's got a value. And yeah, I think I need to expand the test for that. Right now, I'm just seeing that the length is greater than 0, which means it exists in the properties database. Okay, so to access that properties database, we have 3 functions. We can look for just physical properties. We can look for appearance properties, or the way it was done in the previous versions of the application, just a single properties dictionary. Okay. And then we see what's in there, and we can get their values as strings. Now, this is the newer approach where we would call an API to get a physical value and the name of the property. Now, in this case, it's a quantity. So we have user string, which can show you the string, or we can access it by value, or we can get its units, or whatever we want to get about that information. The APIs for arrays have not been finalized yet, so watch this space. There is similar tests for the C++. Okay. Okay, so this again is the Calculus Steel model. We check that if it has the physical models, if the models are complete, if it's in the property dictionary. Where are we? get the physical quantity, get the physical values, and so on. Okay. So that's the API. Libraries. As I mentioned in previous slides, the libraries can be defined, or rather you can define a library for each add-on module. And the way you do this is through the preferences system. So here's an example of how I've defined it in the Rocket Workbench. Okay, so we get the parameter base. So this is resources modules Rocket. At material resources modules, and you would have the name of your particular workbench, in my case, Rocket. Okay, you would add a module directory, which is the materials, if you have material definitions. You can have a separate model directory, which is the models, if you have model definitions, and an icon to associate with each. So if we look at how that's done in FreeCAD, you can see, for example, we have an icon for the user folder, an icon for the system folder, icon for the Rocket Workbench, and so on. And same if we're using the legacy editor, we go to FEM. Okay, so those icons are shown with the different materials as well. Okay, so it's a very simple interface that's available right now. The future interfaces for having external modules and web services and so on, that'll come down the road. Okay, so the material editor, I've mentioned this already, but it's worth reiterating. By default, you're going to be using the legacy editor. The material button that's on the materials workbench in my development branch, it's not merged yet, will always bring up the new editor, but within the various workbenches and other parts within the code, it's going to default to the legacy editor. If you want to change that, you have to go to the material properties and uncheck that box. And actually, an important note about material properties too. All of these used to be in the FEM workbench. They're not anymore. They've been moved to their own preferences tab. Okay, so all of these existed prior in FEM. Yeah, so with the new editor, we get the flexible property definitions. With the older editor, we don't. We can read the old material cards, but as I mentioned earlier, you're going to have to save them before you use them in your current projects. And the main reason for that is as we load in the old format card, we then assign a new UUID to that card. And in order to reference that, it first has to be saved in the new format. Okay. So as I mentioned, we also have the Python utility for bulk conversion, and the legacy editor will be available at least until version 1. Hopefully we can get rid of it before that and this option goes away, but yeah, we'll take that as it comes. Okay, so that's all I have on my list of things to talk about. Obviously, questions are welcome. So raise your hand if you have them, or just speak up. We're not a huge crowd here, but do remember that you are being recorded.
I've only got one question.
Mm-hmm.
Do you plan to provide some Python constants for UIDs associated with the material models? Because using UIDs in code is not really great for readability, especially when it comes for PRs, etc.
That's actually a very good point. So I haven't done it in Python at this point. Again, most of the time, the UUID isn't going to be important to you because you're selecting these things through the user interface. However, it can be important in things such as if you're looking for linear isotropic or isotropic linear. Yeah, I forget it anyway. But yeah, that's going to be important. So I don't have it in Python at the moment. I do have it in C++. So we have a header that defines those UUIDs. And exposing that to Python is something that I think you're right should be done, but I haven't done it at this point.
Okay, that's nice to know that it is exposed in C++, so it should be trivial to do in Python as well.
Yeah. Oh yeah, I'm not scared by the complexity, that's for sure.
Yeah. Thanks.
Any other questions?
Yeah, I got a couple of things. The right now the default is to use the legacy one and then turn on. What would be the trigger to flip that over? At what point are we ready to make the default be the new one, and people can switch back to the legacy one if they need to?
Basically, once the workbenches in question have been tested. So, for example, FEM is one, Arch is another. Actually, I'm going to back that up a bit. Really, it doesn't have to, because the way that's implemented currently is if you are calling the old functions to launch the editor, it checks that preference, and based on that, it'll launch the legacy. If you've updated your workbench to use the newer APIs, you're using a different mechanism for launching the editor. So, for example, from the material workbench, it always launches the new editor. Okay, so it may be worth keeping around a little bit so that external workbenches have the opportunity to transition. Yeah, so it may not be a good idea to take it away once 1.0 is released.
May not be. I don't understand the conclusion.
So basically, if we have an external workbench that's still calling the old functions to launch an editor, we can maintain this option in there so that they can still operate after we release. So if we switch it out before we release, that means that potentially means that existing external workbenches would no longer function. So I think we may need to keep it around for a while.
Well, keeping the legacy one around for a while, absolutely. But the question is, which is the default? And the
on release for 1.0, I would say would have to default to the legacy. Again, okay. The reasoning for that is as FEM, as Arch transition to the new API method, they're going to directly launch the new editor. So they're going to use the new one anyway.
Right. Okay. Yeah, just because switching the default will encourage people to, as long as the default or the legacy one is the default, there will be very little pressure on the add-on developers to convert to using the new one.
Well, I mean that's a policy thing, right? So we can assert, for example, on release of 1.0 that it would go away with 1.1. So that gives people time to transition and a warning that it's going to transition.
Right. Yeah. So the let's see, I had a couple of other real generic things like you didn't really show in the demo using the editor to create a library versus create contents in a library, or did I miss it?
No, you didn't. Generally speaking, they're not creating a library. Okay, so the library is created for them. So the system library, the user library, and the custom library. Okay, so those are same as what's in there now. The new capabilities allow workbenches to create their own libraries, which they can do, but it's not something that users are typically going to want to do. Once we get into the APIs for libraries, where we could add the external, database, web services, and so on. It would be easy to add an add-on module that would allow people to create a new local library, but honestly, there's not a lot of need for them to do that. So
What about creating folders with that? That is
yeah,
within the
okay.
editor.
So yes, the folders is not completely implemented yet, but it's worth talking about. Okay, so again, system is going to be read-only. So you're going to be stuck with whatever folders are there. But some of them like Rocket or whatever, you should be able to add them in here. Now it's not implemented in this particular dialog yet, but where it is implemented in the save dialog, we can create a new folder. And then we can create a new folder under that. And we can rename them. And so on.
Okay.
And then we can save this one, and that'll go in the Henry folder. So if we look down, yeah, there's the one we just saved.
Okay.
Now,
Yeah, I would think that
there's a lot
this-
of other things that are going to be improved in this workflow as well. So for example, right now, when we bring it up, all of the folders are automatically expanded. One of the refinements that still needs to be done to this is to save the last state of it, so that if you had it expanded last time, it'll keep it expanded. Otherwise, it'll keep it compressed. So you're not opening up with this big list of things that you have to close down first.
Yeah, I would think that this is an area where we could do a lot with, where like the UI UX folks could do a lot with a Q abstract data model and bind these things and be able to drag them into folders and, you know,
so this all needs drag and drop and all of that kind of stuff.
Yeah.
And that's stuff that's going to be added to it. Some other features in here, you can see we have the recent ones, the ones we most recently interacted with, but we can also add favorites by selecting the favorite button, and now it gets placed up there and so on. And similar to remove it from the favorites.
Cool. Yeah.
And that's true in the properties as well. We have both favorites and recent.
Okay. Now, if you hover your mouse over like the system library.
Yeah, there's nothing there at the moment.
Okay, so the being able to file path, how do you know where a library is stored?
Well, fundamentally, I don't want you to. So there's a root definition of the library, and then there's just the path to that file from there. So you're actually going to be able to see things shown down here, but even there, it's like user is the root library and then the folder path to that file. Now, whether or not that's desirable, I'm flexible either way, but we can add it in as a tooltip or so on. Now, there is the parent definition field isn't filled in here. Obviously, if you're inheriting a library, we want to show it here. And then it would be things like, if we're inheriting the appearance, it'll be system:/appearance/aluminum.
Right. I mean, I guess I'm thinking from an end user point of view. I've done a bunch of work and I've got things the way that I like them, and now I want to save. I want to back this up.
Yeah.
I want to back up my own stuff.
So the other thing too is there's going to be right-click operations in through all of this as well.
Okay.
And that's certainly, you're not going to inherit from the library. I need to, okay.
Okay.
There's a lot of work that needs to be done on the user interface for this. At this point, it is functional. There's not a lot of checking. For example, if you're going to overwrite a file rather than create a new one and things like that, there's still a lot of work that needs to be done on this. This, in terms of total work, this editor is the biggest part of the material overhaul. The actual implementing appearance and physical properties, I don't think is going to be anywhere near as intensive as what's required for this.
Yeah. Well, I mean, currently don't have any material stuff in path, but I want to add it. Okay. So if I want to start an initiative and get some path developers involved in this and improve the feeds and speeds calculator to use materials. So one part is, how do you use it's material usage, We can take our cues from Arch and FEM and figure out how to set that up, how the user assigns a material to a model in the path workbench. And then I got to configure these models and properties and materials, or adjust the system one to have, like, I think I want to define about a half a dozen materials in the system library that are enough for steel, aluminum, wood, plastic, and could be used to configure a CNC process, a laser cutting process, maybe lathe turning. Not sure.
Yeah. So here's an example set of models that actually comes from this project, which I think you're familiar with, are you not? So this is for creating libraries of feeds and speeds based on cutting tools.
Okay.
So it's not complete yet because we only have quantities available in arrays, but the arrays here can be, you have a power factor, which is not an array, it's a regular parameter, chip load divisor, and then you would get into the stuff that are, I just had the, speeds. Okay, so the cutter, this would be the cutting cutter name, the type of operation, which would require the enumerations. And then you would get minimum speed, maximum speed, and reference, and so on. So you can actually define that as using arrays and as properties and materials. So it's not even just materials you're defining here, it's the definitions for your cutters.
Okay. All right, that's probably a step farther than, like,
and the reason I'm bringing this up is this probably isn't how you want to implement it. You probably want to do something specific in Path, but the point is you can do it. So this is allowing you to think ahead and that kind of stuff.
Well, but I got to decide. Yeah, well, the fastest way to get the right answer on this stuff is to put up the wrong one. And then people will show up and tell us how to do it right. So I want to start with a basic approach, and I'd like to put up a minimum functionality that uses materials to suggest feeds and speeds.
Yeah.
So from a basic material perspective, I need surface speed, and possibly chip load. Chip load is usually an attribute of the tool, not of the material. Surface speed is going to be the big one, and there may be a couple others that I can get out of Machinery's Handbook, which are used in the common calculations for this stuff. But surface speed is going to be the big one.
Yeah. So again, that's just a matter of defining a property file. If you can narrow down what properties you want, I can create that file for you, and we can put it in there. And then we can add the values to whatever materials we have. So just
I know you can. I'm suggesting you shouldn't. I'm suggesting that what we need to do is start developing a center of expertise in managing these materials things.
Yeah.
So you need to teach a few of us how to do it, so that so that we can write the wiki documentation on how to do it, so that we can do it and then make the mistakes.
Well, again, if you have your property defined correctly, what you're going to be playing with is the values, not the properties.
Right.
So, and that's one of the reasons why we don't, well, I'm not planning an editor for properties, is because they don't change that much, and not that many people are going to be required to do it. So, so as an example of how you can do that, if you want to define, where's my resources? There we are. Let's look at the materials and how they're defined. Okay, so right now, under steels, okay, we have a whole bunch of varieties of steel. Now, they're all in turn inheriting from the steel appearance value, right?
Mm-hmm.
But we also have a generic, or there was one in there, steel generic, there we go. So we could have this one inherit that, and then have your path specific properties in here with some default values, and then the other steels can inherit from this one. So they would have some default values based on steel, which they can then tweak based on their specific variety of steel.
Okay.
Okay, so
Gotcha.
that's where that it is a linear set of inheritance. Each material can only inherit from one, but there can be a chain, right?
Okay.
Does that answer your question?
I think so. I think we're just gonna have to do it. Just have to try it. And
Yeah. And when you get to that point, I mean, with whoever your experts are, just I can help with that, and we can work through that process and see what needs to be done. Yeah, there's a lot of documentation that still needs to be done for all of this, obviously.
yeah. Well, and that's why I want to, the sooner we can get people getting their hands dirty on it, the harder they're going to push that the UI is correct and that the data model is correct and the API is correct. And it's like, it's so far it's been mostly you working on this, and this is big enough that it's going to require more participation to get right.
Yes, absolutely.
Yeah.
Which is to say, white flag, help.
Well, I mean, probably the easiest way to get more participation is we add some features someplace that, like whether it's
Break it,
Path
then
or
people will
someplace
jump
else
in.
is, yeah, absolutely. Yeah. But yeah, getting at that, the system library of materials that are useful, I mean,
Yeah.
And you didn't talk much, I guess. Appearance or material usage is the same in the future as it was in the past. What you've built doesn't change that at all.
Correct.
Is that correct?
That's
Okay.
correct. At least
Yeah.
not.
See, I mean, like from a Path perspective, my stock material is uniform. I'm not applying materials to a surface or to a face. It's the whole thing.
Yeah, so you're with the physical properties and not the appearance properties.
Right.
But by the same token, too, are you concerned with the orthotropic, where wood, for example, has different properties and different dimensions?
Yes, absolutely.
Okay.
I mean, I'm not ready to calculate toolpaths based on that, but it's something that's been brought up, so it's something that we will eventually want to support.
Yeah, and that's definitely something that we want to agree on with the FEM and the CFD teams and so on. So all of those groups are going to be using or could potentially use that property. So in terms of how it's defined here in the materials, but also how it's applied to the actual solid or shape, because you have to be able to specify which direction is which. So we know that in the material that different directions have different properties, but you have to define that in the solid as well in terms of what that direction actually is.
Yeah.
But yeah, I mean, these are conversations we need to have fairly soon, but not too soon at the same time, right?
Yeah, like I said, fast way to get the right answer. Put out the wrong one. I think that's all that I had on my list.
Okay. Good questions. Anyone else?
I don't have a question, but I can add that you have a lot of YAML files, and it would be nice for you to define the JSON schema for them. So if we do not plan to develop an editor that is dedicated for that purpose, we at least have some support in the, for example, Visual Studio Code that you use, and get some nice code completion. So JSON schema would be nice to provide.
Yeah, I'm not sure how schema is done with YAML. Obviously, I'm familiar with XML. I don't know if there's any specific format for defining it other than just, a wiki page or whatever.
Technically, the YAML is just a superset of JSON, so it is defined by the same schemas as you do for JSON files, and it's just the standard called JSON schema, so you can look it up and try to write some stuff.
Yeah, I haven't been documenting it so far because it's been fluid, and I've been trying to get a minimum viable product out. But yes, I'm certainly very close to the point where I need to document stuff. I still need to add the APIs for the arrays, but after that, I will definitely get into the documentation part.
Yeah, I don't think that the schema is important at this moment, but when the schema will be stable, it would be nice to define it properly.
Absolutely. Yeah. Okay. So if there are no further questions, I will stop the recording and I'll try and get this thing up onto YouTube very soon, and I'll post it in Discord and on the forums and various other spots.
Awesome. Thank you, Dave. This was helpful.
Well,
And,
that was the intent.
And if I can be, like I said, if I can be more helpful on the project, and try to get the, whether we get people working on specific materials for the system library, or starting to build functionality and path, I'll do what I can to is make sure we get enough traction here, because I want to move it forward.
Yep. Okay. So I'll definitely contact you if I have any needs, and vice versa for sure. So
Sounds good.
and actually, I will mention this to our general audience. If you have questions, I am on the Discord. I'm looking at questions there. I'm on the forums as well. If you go into the developer material section, there are threads for this. You can always start a new thread, and I do check that periodically as well. So questions always welcomed. Yeah, like even today we're coming up with some stuff that might have been overlooked otherwise. So it's even the small questions can lead to important results. And with that, I shall call the session closed.
Bye.
Thank you very much, and goodbye.
Bye.